So the first two in here normally are managed within your ERP system, and Link does the remaining 6. So in terms of data collection, we're talking about getting data directly from machines, which of course is a great way because there are no human mistakes involved. It's real time. So as soon machine does something, we get, let's say, the parts count of if machine goes to downtime, we know immediately about that and we can react on that. But what's important to understand that this raw machine data, it has a value, of course, but in order to truly uncover the value of this connected machines and connected factory, you need to put this data into the context of execution. And you really need to form what we call a manufacturing information domain, because there is lots of other stuff around machine data which is important, to have as offset information in here. We need to think about closed loop solution where everything is connected to everything, right? Because that's really the strength of this industry, for its connectivity. And within Link, we do connect machine with production schedule, with the ERP, with execution context, with everything else. In Link, we have, and we started, with manual data collection. Now we have an automatic data collection, and with this auto, we are able to read data. We are able to gather this data from more than 140 PLC and I/O controllers, which normally that's where you connect to read data from. And we also support all modern industrial connectivity protocols. The last method, which I think is a key in here, and one of the unique points of Link, is the hybrid method. So that's where we can simultaneously read data from both machine, from PLC controller in automatic way, but we can also enrich this data with manual entry where required. Right, so machine may say I am in downtime, but if machine doesn't know what are the reasons behind, employee may use the workbench and specify, well, that's because there is a material shortage there. We start really data correction with our seat maintenance, and I have a machine which is called MBFA 01, and you would see that there is a section here which is responsible for automation. You specify some key data of what's the model of the machine, what type of PLC controller, in my case it's virtualized Siemens controller, IP address to that controller, and so on. That's pretty much all we need. Then our software will automatically connect to this controller using the right drivers, so industrial protocols, to read the data in. So now I'm actually going to show you how this factory automation works, and I will run this simulator that we have in our software. So what you have in here, you have a line, and this line produces boxes, and this line has these tags, so this signal. So what I will do, I will say, hey, on that machine, I'm starting the job number X, let's say operation 2, and I'm hitting start button. So as soon as I click start button, machine will start to produce these boxes with the speed of 3,600 units per hour. So that's 1 unit a second, and my good parts count is growing. Every time the orange box comes in, my scrap information will go. Here on the tag, so that's exactly what you would see on the PLC controller. You see active task, you see good counter increasing, you see serial number, which is like a timestamp changing every time part is produced. Then you see scrap and scrap reason code. It's currently overweight, that's for that box. And you see state of the machine, which is running. And then you see the monitor of how this information flows into the system. What I will do now, from the supervisor perspective, I will go to my equipment status. And here is my machine. I have a couple of jobs there. So another job is started on another PLC controller. I see my parts count. I see that there is KPIs updated immediately there. My green indicator in here says, hey, my valid data is coming. Overall equipment effectiveness. Here it is. I see my total effective equipment performance. Same time, I have the metrics to my employees. So that's my operator. And that's his KPIs that are completely driven by our connected machine, and this data coming in impacts his performance and quality metrics, giving us overall labor effectiveness. So if your machine reports the data, you immediately see, how your loss management picture happens for that machine during that day. So I see my availability reasons. So machine was in tooling failure downtime, read automatically from the PLC controller in unplanned maintenance. I see my performance loss and where it came from, equipment wear, component jams. That's probably data reported manually as a hybrid option in the workbench. And I see a quality loss again coming from the machine, and that's pretty much scrap reason codes it captured in the last couple of minutes. So what it gives us, ability to connect machines, ability to have all of that as part of a closed loop solution in Link MES. That's digitalization. The whole idea is to drive your factory performance. And how to do that? Well, you need to improve visibility across manufacturing operations. You can make more informed decisions with a real-time picture of your operational status, especially if you talk about machines and machine state, because normally machine hour is quite an expensive hour, and any downtime there really has a high cost and high effect on subsequent production flows. uh, Improve effectiveness, because if everything works as it should, its issues are prevented, you are maximizing equipment availability, performance, quality. By doing that, you're reducing your cost of production, because you eliminate loss, right? You can see the loss immediately, you can gain this intelligent analytical insights that we provide, and you optimize your production to eliminate this loss. You are reducing time to market. Again, by analyzing what's happened, you can fine-tune your production processes to build more optimal manufacturing flows. And in the end of the day, you increase your factory performance. And that's, again, I can't stress more that it's very important to have a closed loop solution, unique manufacturing information domain, which starts from planning, goes to tracking, data collection, automation of data collection, analysis of this data, and hopefully optimization of your production flow.